me to such a fantastic place. I think the trip from London, which was seamless in every capacity from the moment we left home to the minute we hit our hotel, was just breathtaking. The beauty of the thing. And I had Wi-Fi on the aeroplane. That was so cool, being able to Twitter and Skype on an aeroplane. Thank you, Norwegian Airways. Okay, so I'm Ian McNicoll. Some of you know me, most of you don't. My background is I was a GP in Glasgow in Scotland. So apologies if my accent is a bit challenging, but I've lost most of it over the years. I haven't practiced medicine for about 15 years, and I'm now really full-time, certainly for the last 15 years, been working in health informatics, although I started this kind of crazy stuff nearly 30 years ago as a very young GP, and effectively as a hacker, as a clinical hacker. You know, somebody who got in about ZX Spectrum and the Apple II. You know, that's where I cut my teeth. With pre-PC days, PCs hadn't even been invented when I started doing this. So I'm a really old guy, you know. I'm up there with the dinosaurs. I do a few things. I'm a director of the Open EHR Foundation. Many of you will know that I have been working and continue to work with ocean informatics, both UK and Australia, for many years. But currently I've now got my own little consultancy company called Fresh Air. And I'm also a director of a thing called HANDI-HOPD, which I'll tell you a little more about. And this, to some extent, this session is about the HANDI philosophy. And if I skip back to my previous slide, it's how do we support this health apps revolution? You know, I think we all recognize that things are changing. And a lot of it's hype. You know, Fabio showed you in the previous session the lifestyle apps, the wellness apps, the tracking apps. As an old grumpy GP, I find a lot of this a little, you know, it's a bit, you know, crazy stuff. Nevertheless, I think this stuff is going to change the world in many ways, and it's certainly going to change medicine. And this group, handihealth.org, is a not-for-profit that was set up to try and support this kind of activity. So it's a not-for-profit in the UK. It's there to support developers. It's there to support health and care professionals and patient service users and carers. And it's about apps. But when we talk about apps in the Handy environment, we don't just mean mobile devices. We mean something which is pretty well constrained. It might be on your mobile. It could easily be on your desktop. But it's kind of self-contained. It will generally plug into something else, either physically, and Fabio talked a little bit about that with the Smart Apps platform. But it may just plug in a sense of interoperating with other components. You know, how our Facebook apps work, how our train timetable apps work. They talk to other services. This is the world that we're interested in, not necessarily mobile. It doesn't matter whether it's on a particular device or not. So it makes heavy use of other things. You know, it's a small, lightweight thing that does one thing very, very well, and a lot of the heavy lifting is done by some other service somewhere in the world. It's built using a well-defined development and deployment framework, and it should be 1,000 million times faster to develop because you're just working on one little bit. It's also 1,000 million times faster to fail. Okay, one of the big problems we have with health projects is we set out to boil the ocean. You know, we try to procure enormous systems, enormous things that after a certain point in time, even when everybody realizes this is a really dumb idea, we've all spent too much time, effort, and reputation, and it just will fail over time. One of the philosophies in here is build it fast, see if it works. If it works, great. If it doesn't, can we make it better? If not, ditch it, okay, and move on to the next thing. So very different way of looking at the software building world. But it's happening already. You know, you can see this happening already, not in health yet, but in other sectors. So what does Handy actually do? Well, it lobbies for the environment in which this kind of thing can happen. Technical, cultural, commercial, in which apps can flourish, and the people who build those apps can interoperate and get orchestrated. So it's all about platforms, kind of business models you use, about standards, obviously, tools, services, approaches. But it's not about building anything itself. Nobody in Handy builds things. We're not an app development company. We're not a consultancy service. We're very agnostic about how this thing is put together. We're not saying you should use iPhones or Androids. We're not saying you should use JavaScript or Python. We don't care. It's the overall picture that is important. Show the community the possibilities and let people deliver it. And we don't care about business models. Open source, closed source, something that sits in between. That's up to the market to decide. That's up to stakeholders to decide. This all has come about in the UK at a very interesting time. And this may not translate to Norway or any other European country. Curiously, I think it's starting to translate to the US. So I'm just going to run through a number of themes that have come up in the UK in the last few years. And one thing to recognise is that Britain, is actually 4 countries. In terms of health and health IT, the 4 individual countries within the UK actually work completely independently now. There's almost no technical interoperability in that sense, or even cultural interoperability between the 4 nations, which is weird. Pre-devolution. So, a few themes that have emerged. I mean, I guess you guys all know that the UK, or at least England, Scotland didn't burn the money. England burned £12 billion in pretty well a failed system. Out of the back of that, and out of the back of the recession and governments looking for value for money, not wanting to waste money, a whole number of interesting themes have emerged. And I'm sure some of these will resonate in Norway and in other European countries. Open data. You know, let's get the data out there and let the analytics people get their hands on it. Again, Fabi was talking about this earlier. You know, can we do much better quality monitoring? Can we divine new and interesting facts from just getting big data and lots of analytics? But behind that as well, open APIs and standards. How can we get the data that's in systems interoperating and out into the outside world? These things are very UK-focused, the first 2. These are about UK interoperability standards. GP2GP is an interesting one because it's an existing project in the UK that lets completely disparate GP systems talk to each other. That was very hard work to get going. It doesn't use archetypes or any kind of modern technology yet, but it's probably the model of actually getting different systems to talk to each other, which is really close engagement by all the people involved, clinicians, developers, just getting in a huddle and nutting it out, you know, wrangling this thing together. There wasn't any clever technology or ontology or coding systems. It was all about people just working through the problems in a kind of iterative process. We're going to hear about some of these newer pluggable technologies, Smart Platform and FHIR. FHIR's the new and very hot HL7 RESTful interface methodology. But also a huge amount of interest in open source. And this comes not just from within the NHS, but it's actually top-level cabinet government in the UK. You know, David Cameron and the guys that he talks to every day are really pushing the open source agenda in the UK. Now, whether you think that's a good thing or a bad thing, technically or commercially or whatever, it's a reality. It's a commercial reality that if you have open source offerings in the UK at the moment, particularly in the health sector, nice things tend to happen to you. So we've got some kind of headline applications. Open Eyes is one that was built by Moorfields Eye Hospital, one of the leading hospitals in the world. Wardware is a small company working with vital signs observations. There's one that Ocean Informatics is involved with, not open source, but an open platform, which I'll talk about. Spine 2 is interesting because that is a big kind of centralized system. Spine 2 is the thing that really handles all the demographics transmission. So all the patient details, wherever they are in the country, talk to this thing called the spine. It had to be reprocured 2 years ago, and it was reprocured as an open source offering rather than the previous one, which was British Telecom, you know, traditional big closed source company. So, you know, the government isn't just talking open source, it is awarding contracts to people who have an open source offering, which is interesting. Whoops, I went all blank. What did I do there?
Open source.
It's open source. Thanks, Tomas. I converted these I moved from my Mac to PowerPoint, so something's not come over properly. I can talk to this slide. So one of the other big themes, I'd skip something, yeah. One of the other big themes is clinicians who code. Okay, the idea that we have to get clinicians directly involved in coding. Now, I can see all the developers going, why would you ever want to do that? And I can see half of the clinicians going, why would I ever want to do that? But that's where I started. And I firmly believe that actually it's a good thing. Okay, it's a good thing that young clinicians, or older clinicians, not be ageist about this, should have some understanding of what's happening under the tin. So I fully applaud this kind of idea. What I'm not so keen on is that some people within the NHS think that that's the way that everything will happen in the future. It'll just be a monstrous army of clinical hackers like me who solve all these serious technical problems. That's insane. Clearly that's insane. But as long as we've got a kind of sensible balance about this, we're doing okay. So, the handy vision, if you like, is about this, all right? It's a bunch of little apps sitting on the top, doing what they do best. Big ones, small ones, bill-sized ones. In the middle, a lot of services and repositories, pathways, patient health record, EHRs, drug knowledge repositories, terminology servers, and then some infrastructural stuff down the bottom, the kind of technical layer, spines, security brokers, record discovery, that kind of stuff that's actually all been worked out. That's the IHE thing that Fabio was talking about this morning. What we tend to have at the moment, one of the fashionable areas, one of the growth areas, I think, in most places in the world, is what you might call a closed health platform. So people will say, we have a platform. Come with whatever application ideas you have. You can build it on top of our platform. And that's true, of course. But you have to do it their way. You have to use their clinical content. You have to use their API. You have to use their kind of querying and persistence layer. Yes, you will get some interoperability between anyone playing in that closed platform space, but it's still a silo. And it doesn't take us very much further on. What we really need is an open standards platform. Okay, so you've got the apps at the top. Ideally, you've got some open source components up there. Okay, so this is stuff that just has to happen. Terminology servers, pathways, integration components. If the people down here are having to interact, or these guys are having to interact with this layer, why don't we just do that in common, rather than everybody having to build it each time? So down at the bottom, we've got a range of different vendors, some open source, some closed source. I think we should be completely agnostic about that. And we've got some standard APIs and messaging content based on open source clinical content definitions that lets this work as a much, much richer infrastructure. It means there's no direct connection between any of these things. You can mix and match. You can start working with vendor C or vendor D, who's closed source. You can move to vendor C, who's open source, and then realize that their offering isn't particularly great, and you can move back to something else. Similarly, you can change the bits in there, and you can certainly swap your apps at the top, as we all do. We get the latest and greatest. We swap from Google Mail to something else and back again, depending on what gives the best offering. That's the kind of environment that we think we should be aiming for. And better still, we think we can underpin this really well with OpenEHR or other archetype-based modeling systems. There are alternatives. We're going to hear a little bit about 13606. In the States, there's a thing called SIMI, which I won't talk about too much today, but there's a lot of interest in this kind of environment, surprisingly, in the US of A, which you would think is solidly still in the commercial model. Okay. So, a couple of other observations from a clinical informatics point of view. Interoperability is probably the really, really tough bit that still hasn't been solved. The ability for these little apps to talk to each other in a health domain. We know it can be done in other domains. It's not as easy as people make out. People, talk about the banking industry as being, the banks can do it. Actually, the banks are just as much of a mess, but they hide it better because they just spend money to hide what's happening. As a weird sideline, I built accounting applications for GPs for a number of years. Actually did the software development. And believe me, there is no standardization in retail banking output. It's all, a single different message type. So let's not let's not get too hard on ourselves in the health environment. We're actually not as bad as sometimes people make out. Okay, interoperability is not a tech problem. Okay, there are many, many different ways to move data about. It can be XML, it can be JSON, it can be HL7 v2, v3, CDA, OpenAir 13606. Pays your money, takes your choice. They all work pretty well. Some have advantages, some have disadvantages. There's always something new and better coming along, but we have a million ways of doing these things. Not a problem. Similarly, we've got all the kind of internet technologies that we need to actually get stuff from A to B and that communications layer. That's not the problem. The clinical side is the problem. Interoperability in health is a clinical problem. It reflects diverse recording practices. In other words, although myself as a GP and another GP might just do things subtly differently, certainly myself as a GP and an eye surgeon are quite likely to do things a little differently, even if we're actually thinking about the same clinical idea. So one of the bits of work we did was with the Open Eyes team to build a visual acuity archetype. So that's for measuring your eyesight. And my experience as a GP was that is a very simple idea. You just take a simple measurement, 6/6. And I thought, well, it's a little complicated because in the States they have a different measurement system. They use feet rather than meters. But yeah, that's easy to do. But actually, when we took this to the ophthalmology community, to the specialists and then to the super specialists, we ended up with a really very complex visual acuity archetype. We don't understand that we do differ, and we need to have those conversations. So, diverse recording practice. Sometimes it's arbitrary, sometimes it's not. Sometimes it actually reflects the fact that we do need to record things a little differently because we work differently. It is just a very complex area, and it's very contextual. In other words, knowing the circumstances in which a bit of information was collected is often just as important as the data itself. So the analytics people get very, very excited about just getting the data points, the systolic and the diastolic and the blood pressure. But if you're a frontline clinician or you're working with apps, you need to know all the other stuff. Where was this taken? So a blood pressure that is high, is that because the patient has just had surgery? Or was it taken in the GP surgery when it shouldn't be high? The context of it, who took it, where it was taken, what else was happening at the time. Has the patient just rushed in because they were running late? That will put their blood pressure up. All of these things are critically important to frontline clinicians and need to be recorded. So, very complex and very contextual. And we have a real problem with getting clinicians involved in thinking about clinical information. It's hard enough to get them engaged in actually thinking about the application building. Getting them involved in thinking about the information underneath that is doubly difficult because it's a little bit abstracted from the real work. But of course, it's all very well helping a developer build an application that suits you so you can get everything in the right place. But if you're going to move the information to a colleague or to a patient, also who may be using a very different application, very different screens, different device, you have to think about the information in isolation. I mean, that's the shared world that we're trying to get to in health. So, current clinical content standards methodology is actually the antithesis of agile development. It's anti-agile development. It's completely inaccessible to the people who should be doing it, the clinicians. It's very slow to develop and doubly slow to actually implement. And I'm talking in the UK context here. This is the CD implementations, the HL7 CD implementations, which are nominally the standard, are nearly all dumb documents. Okay, so they have a wrapper, a document wrapper, but effectively there's no rich content in there. Blood pressures aren't structured, problems aren't structured. It's just a PDF, basically. SNOMED is very popular in the UK for historical reasons. The GP systems all use the read codes, which is one of the kind of previous, one of the things that SNOMED developed from. So people are very interested in using terminology, and it undoubtedly has a key role. But because of that earlier involvement, it's often oversold. People think that terminology will do everything. We just throw more codes at the problem, and that will sort it out. And that's not going to work. The key thing is, though, that it's completely uncontrolled. Okay, there's no proper change request mechanism. There's nothing that lets people say, I have a new idea, how do I get that implemented? Not in my system, but in our systems, in shared systems. So that means that we've got multiple definitions of technical messaging models. And I work that we have approximately 20 different definitions of allergy across the UK. So this is GP systems allergies. Now, there are only 4 GP systems in the UK. They all talk to each other already through the GP to GP messaging standard. Now, you would think that's a great basis. Why don't we all use that? But we don't. Everybody goes off and develops their own thing because they don't know where to go to find out, how do I express allergy? So we've got 20 different definitions of how to collect our allergy. There's no clear change request problem report mechanism. Formal standards is supposed to step in here. But arguably, Ewan Davis, who's a friend and colleague, famously said this. He's regretted it since because he keeps getting shouted at by people from the standards community. But he did say, arguably, standards just get in the way. I'm looking at Gunnar here. He's frowning. But what he means is, arguably, at this level of detailed clinical content, I think often standards bodies do get in the way. And it's not the standards themselves, it's the way we develop them and manage them that is the problem. It's the methodology, not the people involved. So we have a standards body called ISB, and it's still largely a paper and committee-bound process. So if I have a new clinical idea that I want to get developed in a system and share with colleagues, I will submit that. I think it may be electronic now, but it still goes through a committee system, and it will be reviewed. They'll get around to publishing it maybe after a year and a half, and then they'll set a review date for 3 years. Now, that's not how software gets developed anymore. We don't do it that way. It's all agile development. If you need a change, you submit a pull request and you say, I want this changed. What do you think about it? You might get a no, but at least you'll get something happening. So it's just broken. It's just slow, glacial review cycles. There's also a very interesting bit of work happening in the UK by this body called Professional Record Standards Body, it's a good thing. Okay, before I get rude about it, I'm going to say it's a good thing. So this is probably the first time in the UK we have clinicians actually saying the way we record clinical information is important, and we should take hold of the responsibility for standardising it. Because up to now, that's been regarded as a technical issue. We're not interested. We'll just do what we do, and it's up to you technical guys to sort it out. It can't work. It can't work. As clinicians, we have to take responsibility. So I very much welcome that development. It's a good thing. However, what it produces in terms of output is basically paper documentation with high-level headings that are simply not computable. They're aspirational, they're good things, but they're divorced from implementation. Now, I got into terrible trouble because I presented this slide about a year ago. I got in terrible trouble. I had all sorts of people who were, if you like, the targets for these comments, saying how terribly unfair I'd been. Much to my surprise, about 3 weeks ago, I attended a meeting in Brussels where the same people basically presented the same slide with their solutions. So for once, somebody might have been listening to me. This is a very complex diagram that tries to sum up some of this, and I'm just putting it up because it's one of the things the Open Air Foundation, amongst with other partners, tried to do towards the end of last year was to bid for a fairly big pot of money that was allocated to try to get some new developments, particularly into secondary care hospital systems in the UK. A big chunk of it was set aside for open source development. So we tried to put together this picture that we called Orsini that is pretty close to what you would think of as the handy apps model. So up the top, we've got a clinical content service, so that's archetypes. We've got different people using, and then down at the bottom, we've got multiple different open air systems that can all use this independently. And we also thought that the way we do clinical modelling would work very well in terms of defining some standard APIs that people who didn't want to use OpenEHR could still use these as the basis for their APIs to let their systems communicate to each other. We bid for it, no interest, didn't get it, turned down, because people couldn't get their heads around what this actually means. It sounds like magic. It sounds just theoretical. And obviously, one of the things that we were really pushing in that, and the key to it, is this idea of open shared data models, archetypes, clinically led, collaboratively authored, open source, and now all of the archetypes that we're publishing, certainly in UK and internationally, are being published and mirrored out to GitHub, so people can genuinely see them. They don't have to go through the formal tools we're using. You can just download them and use them if you want. And it is critical to go back to this critical point. They have to be agile. We have to be able to respond to continually changing clinical demand. It happens every week, every month. Somebody comes up with a new idea or a variation, a new requirement that nobody had thought about. It has to be fast enough to meet the demands of the app developers who go, hey, I've got a cool new... Well, I'll give you a great example. At the weekend, I was at a meeting where somebody was using an Xbox, I don't know what you call it, the thing you wave, what they call jump controller or something. Thing you wave at the screen if you're playing tennis on your Xbox. They had wired that up to Chromecast. The technology's beyond me, but they were using that and say, look, we may be able to use this to detect whether a patient has a tremor that's associated with Parkinson's disease or some other kind of thing, because you get these gadgets give you very, very fine-grained location of tremor. And you can see if someone has a tremor, you can see that the little graph wiggling on the screen as the data comes back from the device. Now, that might be a crazy idea, but it's the sort of thing that suddenly there is a demand for new clinical content. Somebody says, well, I need to record that. I need to record all sorts of information about that device. How does that happen fast enough? I forgot to say tight version control, okay? If we're going to make these things so that they fit well and get into apps, and if we're going to be changing them all the time, we have to be very strict about how we version control them, because otherwise the semantics all get lost, the APIs all get messed up. So here's an example of an archetype that we developed in the UK for part of a Leeds Care Record project, just to see that this isn't all about blood pressures and analytics and figures. This is about what's called in the UK DNA CPR. DNA CPR stands for Do Not Attempt Cardiopulmonary Resuscitation. Okay, if this person has a cardiac arrest, leave them alone. We need to get that standardized so that anybody in the chain of command, anybody in the pathway of that patient's care, can know very precisely and very quickly whether they should start trying to resuscitate this patient or not. So archetypes are not just about, the figures and the numbers. This is about the practice of medicine. And these are based on ISB standards. These are based on standards that were already developed. How does that work? Well, that's turned into an archetype, and then it's turned into a template, and then we generate documents from that. But all highly structured, all queryable, using the sort of technologies that Fabio was talking about this morning. I said before that when we kind of addressed this a year ago, there were kind of blank looks and, go away, we're not interested. Curiously enough, some weeks ago, I attended a meeting in Brussels, and some people from the NHS internal stood up and said, hey, we're using archetypes. And I went, I didn't know you were using archetypes. Complete news to us. They're using David Monner's tool. Is David here? Yeah, he's up at the back. Who's on next? So they're developing archetypes. They're not open-air archetypes, the 13606. If you don't understand the difference, don't worry about it. It's the philosophy and methodology that matters here more than the exact technology. So they're taking, over there are these high-level headings that I was talking about, this professional record standards body stuff, and they're creating archetypes from them. So we're making progress, I think. I think the final thing that's going to make the difference in trying to persuade the world that we've really got something interesting here is just to have something that is real, that's a demonstrator. And I managed to persuade my colleagues in HANDI that there was enough in this community and around all these other things like SMART and FIRE and 13606 and archetypes and all this kind of blend of technologies that we could actually show our handy community how the world might be in the future. We're not saying this is how it must be, or not. We're certainly not marketing this as a commercial tool, but we've got some support from a number of different vendors, a number of different volunteers, effectively, to put together a thing we've called HANDI-HOPD, Handy Open Platform Demonstrator. So, the philosophy is a new mobile app developer, maybe this is the Chromecast thing, requires a plugin to record, in this case I've said to record some test pulse app functionality. But this app developer, they've got a really nice tool and it works on an iPhone, but they want to hook it up with a wider community. They want to hook it up to other systems to do the kind of analytics or just frontline care that Fabio talked about this morning. So we envisaged something a bit like this. Up at the top, ignore the bit at the very top, that's UK specific. Smart platforms, which is this pluggable web app. Fabio mentioned the growth chart plugin. That's what we think. Then we've got this HL7 Fire layer, which is a technical layer. It's a very nice, fairly simple way of getting people up to speed with it. But underneath that, whoops, didn't mean to do that. Underneath that, we have archetypes coupled with SNOMED clinical content definitions. And this is the technical stack, if you like. Down at the bottom, we either have the open-air data stores, so that would be something like the ThinkMed platform that Moran used, the OceanAir platform, but there are several others in the wings as well. We'll hear about them over the next 2 days. So plug and play, not one vendor. We've got at least 2 vendors, probably 3 or 4, that we would like to have in there over the coming weeks. But other people can use this. They don't have to have full commitment to the whole open-air stack. If you've got a non-open-air system, maybe you just work with the fire layer there. But critically, the really important bit, the clinical side, the stuff that makes this work, comes from the clinical information modeling service around this side. Now, again, I don't care whether it's open-air or 13606. I think that's another discussion another time. But this lets the technical guys deliver the best technology, but feeding on the clinical ideas coming from, if you like, my world on this side of things. So, in putting together this HANDI-HOPD model, the first thing we went to do was to have a look at the AirScape tool that Fabio showed you briefly this morning. So this little slide shows you that growth chart smart platforms thing, which is really, really nice. It's a really pretty bit of visualization of child growth charts. So we took that, and we certainly make use of their APIs as a start point. We're not saying we're going to finish there. And we effectively forked it with their permission. It's all up on GitHub. You can go and download it if you like. We have better-looking patients, and we have better-looking doctors. But other than that, it's pretty well much the same. One critical area where it's different, here, okay? The data here doesn't come from the ThinkMed repository originally. It actually comes from work that Ocean Informatics did in Leeds, pulling data from GP systems. And this is dummy data, but it's realistic dummy data, if you see what I mean, because it was used for testing purposes, and was used in the Ocean Informatics OceanAir platform. And what we did, we just took the data from one open-air repository into another open-air repository without any work being required at all, other than reading it in. There was no transforms, there was no hacking, there was no XSLT, there was no anything else. It just worked. We asked for it on the Monday. By Tuesday, we'd loaded up, I think, several thousand compositions, documents. And what you're seeing here is data running that was originally captured in one open-air engine, running a completely different technology stack to the one that it's in now. And that itself is really, really impressive, I think. Okay, we just demonstrated, just to getting this working, that open-air is actually completely vendor agnostic. So this data came from, effectively, NHS GP data. So that was a good start. And there's a couple of slides missing for reasons I don't understand. But what I'll explain on the one. So we took this little demonstrator to a thing called HANDI, NHS. How am I doing for time, Louise? I'm okay? It's okay. You okay? Oh, yeah, fine. I'm nearly done. The slides that are missing, curiously, I don't know why, there's obviously some evil intent, because all of the slides that are missing are actually talking about the same thing. And what they're talking about is this. Okay? I was going to wear this, but you're too well dressed. I would have been embarrassed. Okay? This thing is NHS Hack Day. All right? So, nhshackday.org, I think. So this is a slightly crazy idea that the punchline is NHS Hack Day 2014, geeks who love the NHS. So the idea is to get a bunch of developers from anywhere, they may not come from health industry, and a bunch of clinicians and anyone else who happens to rock up on a Saturday morning and see if they can do something interesting over the course of a weekend. And there's quite a lot of beer consumed in the evening before, which helps the whole process. So we thought, hey, wouldn't it be interesting if we could take this little tool, bearing in mind that we'd only actually put the whole idea together about 3 weeks ago. So this was really on the rough edges of getting any of this working. What if we could take HANDI-HOPD to the Hack Day and say to the people there, hey, look, we've got this cool thing working. Come and play with it. Let's see what we can do. So these were slides about Hack Day. So what you do at a Hack Day is you go and pitch. Okay? You get 2 minutes to tell your assembled colleagues what it is you want to do, and then you retire, and they all go and find you and decide whether they want to work with you or not. Okay, so what we set out to do was patient-led medicines reconciliation. So for those of you who are not clinical, medicines reconciliation is the process that has to happen when a patient comes into hospital. And they've got a list of their drugs, maybe from their GP. If they're really lucky, they'll have an electronic feed from the GP. They probably have a bag of drugs that they've got themselves. But all of that information will be wrong. Okay? Guaranteed it will be wrong. Because they will be taking drugs that they've taken, there'll be drugs that they've bought themselves from the pharmacist. There'll be drugs that have been prescribed by a nurse or a mental health team or anybody else in the community, maybe a secondary care physician. They will have stopped some drugs. They will have stopped some drugs and told the GP, and he hasn't updated his records. And I say that as a GP, because that's life. They will have stopped some drugs, as I did, and not told the GP that they'd stopped them. Okay, so the only person that really knows what they're taking, assuming the patient, doesn't have mental health issues or isn't confused, is the patient themselves. So there's a process that goes on, or should go on, in hospitals of what they call medicines reconciliation, where you try to get an accurate picture so that the hospital doctor can say, okay, I know exactly what you're on now. Now I'll decide which ones to stop and start because of the particular condition you have. So they may be going for surgery and they have to stop certain kinds of drug. There's a project in the UK called Renal Patient View, which is probably one of the best examples of real patient health records or patient portals. So this is for patients who have serious renal disease, and many of them are on dialysis. Others have just got, critical kidney disease. And it means they can go and look at their results. It's a kind of passive thing at the moment. They can see lists of medications. They can see lists of lab tests. Very well liked, very well used. And the Renal Patient View people said, look, we have to go through this meds reconciliation hassle every time we go into hospital. It's just a pain. And they're fairly regular attenders, as you might imagine. Why can't we do some of this process? We're used to being engaged with our health. We have to be. We have to check our lab results. We have to check our weights, etc., etc. Why can't we lead this process? So I took this idea and said, can we, over the course of 2 days, create a medicines reconciliation module for patients, not for clinicians, but for patients. So a patient-facing web page for meds reconciliation, populate it from an existing GP source. Okay, so this isn't something the patient types in. They get the feed from a GP system. And then they're allowed to market to say, I've stopped that, or the dose has been changed, or there's another drug that I'm taking. I got it from the pharmacist, but the GP doesn't know about. And then, of course, we want to save that data back to a server and transmit it back to either to the renal unit or to the GP to say, actually, your records are a little out of date. But we want to be in a structured format so that they can very easily check it, and if it's correct and they're happy with the amendments, then they feed it back into their system. Okay? If it's on paper, if it's in a PDF, then it's going to be a hassle to do. If we can keep it in a structured format, they should be able to automate this quite nicely. Okay, so some of the screens aren't coming out, I don't know why. Anyway, this is just some screenshots of this little application. You can see the stuff underneath, sort of. Nah, it's not coming out very well. So this is a little box thing. I've started a new medication, name and preparation dose, and then because. Why have you started taking new medication? A little bit of information about it. Oops, and then you end up with this kind of thing. So the one that's green has been checked. They're saying I take this as prescribed. The one that's in orange is I'm taking this drug, but I'm actually taking a different dose. Okay, so I was taking 1 tablet a day, but it's been changed to 2 tablets a day. The specialist told me to change it to 2 tablets a day, but it's wrong on the computer system in my GP's surgery. This one, I don't take this at all. And in this case, I've said, I'm not taking, I didn't like the side effects. Okay, so this is, if you like, your input. This is the middle, and this is the output. So this is a really, really simple application, but it was built in 2 days by a team of me, a kind of aged hacker who doesn't understand really this web technology. My partner Hildegard, who's sitting here, who is actually a product manager in real life or in a GP system. So she's probably the only one who actually knew what she was doing because we got her to be the product manager. There was a very junior doctor who'd never done any programming in his life, and he designed the bit in the middle. He got onto the web, downloaded some nice Twitter bootstrap graphics, and with a little bit of help from the team, he did that bit. We had one guy who actually did know what he was doing, but he worked in the financial services industry. He worked for the Bank of America, had never dealt with a health app before. And the other people were so useless that I'm not even going to mention what they did, because they did very... No, I beg it. We had one young trainee paramedic, ambulance guy, who actually did do quite a bit. He hadn't done any programming for a year. And before that, it was like a school project, So, this was a pretty rough and ready team. But we got it working, okay? And we got it working that we got the data coming out, we got the transform made, and we got the data going back. And we built it on top of the technology that Fabio showed you this morning, okay? Better still, we built it on top of the technology that used the data that was collected in a completely different open EHR system in a different part of the country using a different technology. That's the data that we were working with as the input, and that came from the Ocean Air server. Thanks to them for providing it. That is the AQL, this mysterious architect query language that Fabio talked about. That's what we did, and that's it running in the little explorer. So I did that bit because I actually do understand that little bit of it, and that's it pumping out a list of medications. And that's the code that the Bank of America guy wrote to get it on the screen. And the key thing is that he didn't write that bit. I wrote that bit. Well, at least EHR Explorer wrote that bit, and we just plugged it in there. We just cut and pasted it. So these guys said, how does the database work? How does the database work? I said, don't worry about how the database works. I'll do that bit. I'll give you the query statements. If you just understand how to get that data out of there from JSON into your JavaScript and onto your screen, that's your job. So talk about distributed working. It worked a joy. Okay, and that's the data coming back out again. So that's what would be persisted back into the system, the right-hand side of the screen. And I built the archetype at the weekend to do that. So here's the next thing, okay? We didn't actually have the database model when we started with this. I built this so that I had a target to. We plugged it into EHR Explorer. ThinkMed, then the back end, knows about that. And then we can then send it a little bit of structured JSON, and it persists it. I could actually do the same with the Ocean Air server at the other end with some tweaks because they use XML rather than JSON. But the data format is the same, and that's hugely, hugely powerful. So having built it for here, we can run it against different services, and that's the goal for the Handy thing. Okay, so where are we going next? Technically, We want to get the SMART and HL7 fire support working with help from people like Ocean, Morand, other technical teams, and we got a lot of enthusiasm and a lot of support for this, and they're keen to help. We definitely want more open air providers. It'd be great to show this thing actually firing data at multiple different services, almost recreating a practice here, a hospital there, whatever. There's lots of ways we could skin this. It'll be very exciting. Cross-provider querying. Okay, we could run the query and say, give me all the medications. Give me the medications that are in Leeds in the Ocean Air server. Give me the medications that are in the ThinkMed server and draw them together. That would be fantastic. And we've already demonstrated cross-provider transfers. We just took it. It just worked. There was nothing else to do. And one of the things we hope it might become is a focus for pulling some of these differences in the APIs together. So I said, there's a tweak because the Ocean API uses XML. And there are subtle differences, but fundamentally these things all work in the same way. We need to do a little bit of work to align them. More importantly, we've just, I think, started to get inside the heads of the people that said no 6 months ago. The ones who looked at that Orsini complicated multicolored Orsini chart and went, that looks like magic, and we love the idea, but you can't make this work. I think we're getting inside their heads, and I'm going to be having some discussions with some of those people within NHS England. There's a group, one of the slides that had disappeared was related to this, getting clinicians to code. There's a thing called Code for Health, which is an actual formal government-sponsored coding scheme, and they are interested in letting their clinical hackers, clinical coders play with something much more realistic than they have up to now. And we hope they might start to see that this approach actually works. This isn't vaporware. It's not academic anymore. It really does work. And to that end, we're planning to have a very specific HOPD hack day. I like this, HOPD hacked hack day in September. And we're, any of you who are interested, if you can drag yourselves away from Tromsø, which would be astonishing, we want to get a real community and maybe even get people joining remotely. Okay, that's me. Clinorac. I was called a clinorac by somebody once. There's a clinician anorak. I don't know if that translates, but an anorak is a geek in English. It comes from train spotters who wore anoraks. I was a train spotter when I was young as well. So that was me in an ice bar in Stockholm, I think. Not one of my better looks. Thank you. Time for questions.
So, on the side, everyone risk. So I would like to know how did you use SnomeCT? Because I saw there was like where you had the architect.
Yep.
Plus SnomeCT. So I'm interested in knowing if you are applying some kind of knowledge discovery or using the semantics behind it to route the information or to
No, it's a little less sophisticated than that. SnomeCT in the UK is really getting pretty solidly established. So when the source data that we got from the original GP system, again, bear in mind this is dummy data, but it was from a real GP system provider, they routinely now map out SNOMED coding. So GP system data in the UK is very highly coded using the read codes, which is a predecessor, if you like, to SNOMED, has been for many, many years. So nearly all of the diagnostic, in fact, I would say all of the diagnostic data, all of the procedure data is read coded, and there's a standard mapping out to SNOMED codes. So that's just stuff that we're getting already. We're not having to do anything. It's actually stored in the mappings part of the DV coded text or the DV text attributes. Similarly, we're getting coded allergy information and starting to get some coded drug information as well.
I have two questions. You said earlier that SNOMED was oversold because of technology, but then you say also that you're very actively using That's one question. And the other one is you're talking about something called DNA CPR.
Yes.
Is that to mean that you
That is a very interesting and good question that I'm going to defer to my friend and colleague Rob Chen, who's going to talk exactly about that tomorrow, if you're here tomorrow. Or is it today? Is tomorrow wrong?
Yeah,
Tomorrow. So, tomorrow night. There's a thing called guide definition language that Ron and his colleagues developed that attempts to do, it does exactly that, okay? Anytime there's an information model, if there's a guideline, it has to have some kind of idea of that information inside the guideline. So I'll leave that till tomorrow. Very good question. The answer is yes, but the expert in this is going to talk tomorrow about what's happening with that.
Yeah, a question about snowmelt.
Yeah. Okay. So I actually would defend both statements. I'll clarify what I mean. So first of all, I don't think if you want to use a clinical terminology in the future or even right now, there is nothing better than SNOMED. Okay, it is, for the rich kind of detailed frontline clinical use, not for, hospital episode reporting. ICD is fine for that. But if you want clinicians to be recording things, I don't think there's any doubt that SNOMED is the way to go, and it's good enough for the majority of places. But SNOMED is built on quite a complex technology, an ontology that they use. And it's pushing the boundaries of that, which some people think they ought to do, is where it gets tricky. There's a thing called post-coordination, which means you can join codes together. So rather than having to have a separate code for left hip, another code for right hip, you can just say, we have a code for left, we have a code for right, we have a code for hip, and we can plug these little components together. At that simple level, it works very well, but it becomes incredibly complex to do. And some people have tried to push that side of it, the post-coordination side of it, I think way, way too far. And actually frighten vendors from implementing it because it's quite difficult to do.
Just another question. How is that compared to mesh?
I'm not a terminologist, so I'd struggle to say, but mesh is more about categorizing things. I don't think mesh was ever intended to be the codes that were used within systems. There's still a fair amount of debate about whether SNOMED is a good thing or not, but I think most countries, you would be hard-pressed to recreate where they've got to now, with all its failings, without all the problems, with all the reservations I have. I wouldn't like to start again. I think, it's about making it better rather than saying, let's do it differently. Because it's actually extremely good. As long as you use it within its comfort zone, it's when you push out to the far frontiers of well, I think good sense, that's when it becomes a challenge.
I will make another question. Are you currently compatible with the interoperability toolkit in the UK?
Well, that's another interesting question. So the interoperability, I barely know what it is. So the interoperability toolkit is a set of services and tools, some are open source, some not, which are really about the high-level plumbing within the English NHS. It's how the spine thing talks to. So it's all about, how you get, broadly speaking, how you get data out of one hospital and into another. It's not really got anything to say about the content. It's really about the plumbing, about the wiring. It's around, security protocols, messaging. It's stuff that's not my domain as a clinician. There are some interesting bits of open source ITK components that have been built. Some of them were used in the project that we were involved with Moorfields, where we moved the visual acuity data, we moved from one hospital to another. And one of our partners built some open source components. So when you saw that in the slide, ITK components, absolutely, if somebody has built that stuff, and it means that app developers can make use of it and it's an open source environment, yes, we want to have that to play with as well. But it's kind of a world away from what we're trying to do, and it's out there already. I've exhausted you. You need more coffee.
You are a GP.
Yes.
And you didn't mention that this architect, because they are consensus documents, so to say.
Yes.
What about professional societies? I'm a rheumatologist. My professional society, one problem is not
Yeah, and I think that's the right thing to do, and it's also generally, and forgive me because you may have worked this out, but in the UK, this is exactly the thing I was talking about with this professional record standards board body. Okay, so that is exactly the same process. So a bunch of mostly secondary care clinicians like yourself getting together, working out some guidelines and standards, and then they go off and they implement them. And they all implement them differently. That's the problem. Okay, so this is the thing to say these are good clinical ideas, and I have no problem at all with that work. But there are people within the PRSB that think that that's all that has to happen, that you just give this to industry, to vendors, and they'll implement them, and they'll all implement them the same way, and it'll all interoperate. And it won't. It just won't. So we have to build on that good work, but bring people in and define the ideas that you're coming up with in a much more rigid technical way, not using technical language, not using technical ideas, but in a way that's fit for purpose, that I can hand to people like Luis and say, just get on and do it. And that's what archetypes do.
So then maybe you should have clinical knowledge manager for professional societies?
Absolutely, absolutely. And that's what we're trying to do in the I haven't shown that, but we actually, in the UK, we're using the clinical knowledge manager product to try to improve the medications data that you saw there is actually built on medications archetypes that were developed from the GP to GP project that I talked about. So it's about getting that. It's not about doing something new. It's about getting that knowledge and putting it into a mechanism that can be used directly, as we did in a system, without any other work being done.
One last question. So the HANDI platform, is that managed at the Leeds Innovation Laboratory, or is just...
Sorry, I missed that.
I don't know if you deployed the platform in the Leeds Innovation Laboratory, or that was just...
No, it's a little complex. There's another platform called the Leeds Lab platform that myself and Ocean colleagues were developed. I'm hoping that we can join these two things together. We should do. I think that may stay as a separate project. But I really hope these two, in fact, I'm sure these two things will talk directly to each other. And again, that's very powerful, just to see two quite different implementations that are able to communicate seamlessly. And keep doing so. It's easy to do that kind of integration once. But what we need to be able to show is that somebody like me can come along with some new clinical ideas, plug them into one repository, plug them into the next, and things just keep working. That's the powerful. Okay.